everyone. Today we're going to be talking about the quadratic formula. And our main goal for today is to understand what is the quadratic formula and how do we use it. It is very important for each and every individual to have a solid foundation on the quadratic formula because it will appear in a lot of one's math classes. Before we begin talking about the quadratic formula, we need to review what the quadratic function is. The quadratic function is a very common function that one begins to get introduced to in around 8th or Algebra 1. And in this graph, what it creates is the shape of a parabola. And a parabola can either be a upside down U or a side faced up U. And as you can see in the diagram, this one is a parabola that is facing upward as a U. And so the following parabola has the equation, the standard equation of y equals ax squared plus bx plus c. And in this graph, there are many important components of it. You have the vertex, which is the main focal point of the parabola. You have the y-intercept, the point at which the graph hits the y, intersects with the y, so it would be a point right here or right here. You'll also have the roots, which we're going to be finding today with the quadratic formula, which are the points at which it hits the x-intercepts. So these are known as the roots. They're also known as the x-intercepts or the zeros of a function. So again, in the quadratic function, there are main parts. We have the roots or the x-intercepts, the points at which the parabola intersects with the x-axis. You have the vertex, which is the main point of the parabola, and you have the y-intercept where the parabola hits the y-axis. So there are three ways that we could use to find the roots of a parabola, of the quadratic function. We could do the quadratic formula, which we'll be covering in this video. We could do factoring, which I'll be covering in the next video, and then we could do completing the square. The quadratic formula is a formula used with the main purpose of finding the zeros, roots, or x-intercepts of a parabola. But later on in different math classes, it's going to have different purposes. So let's write the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's break down the parts of the quadratic formula. So this x right here refers to the roots that we are going to get as our answer. And again, we said the roots are the points at which the parabola intersects with the x-axis. Now, for the letters a, b, and c, those can be found in the standard equation of the quadratic function, which we know it as y equals ax squared plus bx plus c. So when it comes to using the quadratic formula, it is very important that you know which coefficient aligns with which part. So a is always going to be the coefficient of x squared. B is always going to be the coefficient of x, and c is going to be the constants of all our equations relating to the quadratic function. So again, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, a very important part that all should know regarding the quadratic formula is the discriminant. The discriminant is the part of the equation that is inside the square root. So the discriminant is the square root of b squared minus 4ac. This part of the quadratic formula lets us know how many solutions the function will have. So again, inside the square roots, we have the discriminant. And the main important part of the discriminant is it tells us how many solutions the quadratic function that we are finding the roots of, how many solutions it's going to have. By solutions, again, I mean the root. So if this discriminant is equal to 0, the graph will only have one real solution or one real root. If this discriminant is negative, so in other words, it is less than 0, it's going to have imaginary roots. That means it will have no real solutions. If the discriminant is greater than 0, it's going to have 2 real solutions. So again, we have the quadratic formula. The quadratic formula we can use to find the zeros or roots or x-intercepts of a parabola. And one of the main parts that tells us how the quadratic function is going to look like is the discriminant. And the discriminant tells us how many solutions or roots the following parabola is going to have. So let's start with an example. So the following example reads, find the x-intercepts of y equals x squared plus 13x plus 40. And we're going to be using the quadratic formula. First, let's label our a, b, and c. So our standard equation is y equals x squared plus 13x plus 40. Our standard equation, I'm going to write it right here, y equals ax squared plus bx plus c. And we said that a is always going to be the coefficient of x squared. So here our a equals 1. B is always going to be the coefficient of x. So b is equal to 13. And c is always going to be the constant. So c equals 40. Now let's put it into our equation. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Let's plug in our variable. So x equals negative 13 plus or minus the square root of 13 squared minus 4 times 1 times 40 all over 2 times 1. Now we want to simplify. So x equals negative 13 plus or minus the square root of 169 minus 160 all over 2. So again, we simplify. X equals negative 13 plus or minus square root of 9 over 2. Now, we have our square root right here, square root of 9. We know that 9 is a perfect square. So when we rewrite our equation, our formula is going to be x equals negative 13 plus or minus 3 over 2, because 3 squared is 9. Now we solve. So once we get to this point, it's very important to notice this part right here. It says plus or minus. That indicates that we still have those two solutions. So with these two solutions, we're going to have one that looks like x equals negative 13 plus 3 over 2, and x equals negative 13 minus 3 over 2. And then we simplify. Negative 13 plus 3 is equal to negative 10 divided by 2. X equals negative 5, our first solution. Our second solution, negative 13 minus 3 is negative 16 divided by 2. X equals negative 8. So this is how we're going to rewrite our answer. So we know that we have x equals negative 5 and x equals negative 8. To write them as x-intercepts, we'd write negative 5, 0, and negative 8, 0. So the x-intercepts of the following quadratic function are negative 5, 0, and negative 8, 0. That is how we use the quadratic formula to solve for the x-intercepts of the following quadratic equation. Try another example. I would like you to pause the video, try the example out, and then re-click on the video to see how to solve it. Thank you for pausing the video. Now let's start going over the example. For the following equation, the zeros of the function y equals 4x squared plus 10x plus 6 are -1, 0 and -1.5, 0. Please make sure you copy it down. And if you have any questions, please put your questions down in the comments below. Also, if you have any suggestions on what videos you want to see, what concepts you are struggling with, please leave the suggestions down in the comments below, and I'll be sure to read them and make new videos. Now, for our last example, I want to walk you through this example because in this example, we're going to see a different type of answer in the end. So let's start. Again, we want to begin by labeling A, B, and C. So our A is 1, our B is 10, our C is 30. Now we plug it into our equation. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now we plug it in. X equals -10 plus or minus the square root 10 squared minus 4ac all over 2a. Now I want you to solve and tell me what comes inside the square root. So let's begin. So we get x equals -10 plus or minus the square root of 100 minus 120 over 2. And we simplify again. X equals -10 plus or minus the square root of -20 over 2. So in this case, we meet what I've talked about before in terms of the discriminant. In this case, our discriminant is negative. And when it's negative, so when the discriminant is less than 0, it means that we have two imaginary roots which are not real roots. So when you graph it, you'll find that there is nothing that is intersecting the x-axis. So let's continue solving and I'll show you how to solve. So in this case, our -20 does not have a perfect square, but this is how we simplify it. So square root of -20 can be broken down into the square root of 4, square root of -5. Square root of 4 is a perfect square, and that square root is 2, square root of -5. And we don't want to have a negative sign inside our square root, so we rewrite it as 2 square root of 5i. This I represents imaginary, but also says that our square root is negative. And now we want to write our equation once again. X equals -10 plus or minus 2 5 root I divided by 2. And we split them up once again into two parts. X equals -10 plus 2 square root of 5i divided by 2. X equals -10 minus 2 square root of 5i divided by 2. And we simplify. And I want you to ignore the part that says this right here until the very end. So let's see how we're going to do this. I don't want you, so not to ignore it, but I don't want you to be worried about it. So when we simplify this, we write it as individual fractions. So -10 divided by 2 is -5 plus 2 root 5i divided by 2 is just equal to plus square root of 5i. And we rewrite it on the other side. X equals -10 divided by 2 is -5 minus 2 square root of 5i divided by 2, which is minus square root of 5i. So these are our two solutions. And of course, we can simplify it, and we take the square root of 5 and we simplify it to 2.23607. And I know this got a little messy, so I'm going to rewrite it together. X equals -5 plus or minus 2.23607i. So the x-intercepts of the following equation is -5 plus or minus 2.23607i. And again, these are going to split up into plus and minus. And I hope this example was helpful. So again, we saw that we could have roots that are perfect whole numbers, we can have decimals, and we can have imaginary roots, and we were able to find the root for each of them through using the quadratic formula. Review important concepts. So we learned that the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. We learned that inside the square root, it is known as the discriminant. And this discriminant, if it is equal to 0, we have one real solution. If it's greater than 0, we have two real solutions. And if it's less than 0, we'll have no real solutions, but we will have two imaginary solutions. And that is it for today. If you need any help and you would like one-on-one tutoring, please follow the Google form link in the description below and fill out the form. If you have any suggestions on things that you want me to talk about, please comment them down below. Don't forget to subscribe, like, and share with all of your friends to receive the tutoring that they need. Have a great day!